Acids and bases are everywhere. They are in the food we eat, the drinks we consume, and even in our own bodies. Understanding acids and bases is like unlocking a secret code to the world around us.
It's a fascinating journey into the world of chemistry, filled with bubbling reactions and colorful transformations. Have you ever tasted a lemon? That sour taste? That's citric acid at work.
Or how about the fizz in your soda? That's carbonic acid. Acids are known for their sour taste and their ability to turn blue litmus paper red.
On the other hand, bases are found in many household cleaners. Think about the soap you use to wash your hands or the baking soda in your fridge. Bases feel slippery and turn red litmus paper blue. Acids are like the tiny building blocks of chemistry called hydrogen ions, or H+. When acids dissolve in water, they release these hydrogen ions, giving acids their unique properties.
Remember that lemon we talked about? That's a great example of a natural acid. Vinegar, another common household item, contains acetic acid. These acids are weak, but some acids, like hydrochloric acid and sulfuric acid, are strong and can be dangerous in high concentrations.
Acids can react with metals, and you know what happens then? They release hydrogen gas. It's like magic, but it's science. Now let's talk about bases. Bases are the opposite of acids. Instead of releasing hydrogen ions, or H+, they release hydroxide ions, or OH- when dissolved in water.
Think about soap. It feels slippery, right? That's a characteristic of bases. Baking soda, also known as sodium bicarbonate, is another great example of a base. It's used in baking to make cakes rise.
Common bases include sodium hydroxide and potassium hydroxide, which are used in making soap and other products. Section 4. Neutralization, the balancing act. When an acid and a base meet, they react with each other, and guess what happens?
They neutralize each other. It's like a chemical handshake.
This reaction is called neutralization, and it's an important process in chemistry. In a neutralization reaction, the hydrogen ions, or H+, from the acid combine with the hydroxide ions, OH- from the base, and they form something new, water, H2O. The remaining parts of the acid and base also combine to form a salt.
This reaction also releases heat. About 57,000 joules of energy are released during a typical neutralization reaction between a strong acid and base. That's why mixing acids and bases can make the container feel warm. It's an exothermic reaction, releasing energy in the form of heat.
Section 5. Identifying acids and bases. The colorful world of indicators. How do we tell if something is an acid or a base?
We use indicators. Indicators are special substances that change color depending on whether they are in an acidic or basic solution.
Litmus paper is a simple indicator. Remember, acids turn blue litmus paper red and methyl orange to red as well, and bases turn red litmus paper blue.
Another common indicator is phenolphthalein. It's colorless in acidic solutions but turns pink in basic solutions.
Scientists use indicators to measure the strength of acids and bases. It's like having a color-coded guide to the world of acids and bases.
So there you have it. Acids and bases are everywhere, playing important roles in our daily lives and in the fascinating world of chemistry.